Okay, we're working on the paired homework from number 3, I think it was,
Right.
which is 10.83. That's to do with, well, let me read the question. Let me read it out. Let's see. It says,
Actually, that's not it. The problem's right here.
Oh, okay.
It says 2 blocks are connected by a massless cord wrapped around a pulley with a certain radius. The disc can be rotated without friction, so it's basically a perfect pulley. The system is released from rest, and we're supposed to find the magnitude of acceleration and the 2 tensions.
Right, and we found that looking at the structure, this mass is greater than this mass, so obviously the acceleration is going to be this way, which is clockwise. What we did first was we broke it down into its components, the 2 blocks and the pulley, and try to put emphasis that these 2 are linear, but this is rotational, and got all of our notation down. What we have to do first is look at Newton's second law, which shows us the comparative between the 2. So we have F1 equals ma. Looking at this diagram right here, we can solve for t. That's what we did here. Block 2 is the same way, although we put our positive direction in the clockwise direction, so the notation or the formula is going to look just a little bit different. And this is the tricky part right here, dealing with the pulley. We set all of our torques, or we recognized them all, and we found that the torque for the normal force and the torque for the gravity is 0, which leaves us just the torques for the 2 tensions. And knowing all of this, how to determine the difference between acceleration and what is this?
Angular.
Yeah, angular acceleration.
Alpha.
Yeah, alpha. And then knowing that the torque equals the R perpendicular F. Knowing these 2 things, we can figure out what the torque of the tensions are going to be and solve for A, which is the linear acceleration. That's what we're looking for. And so inertia for the disk was 1/2 mr squared. And so what we did was we took this formula over here.
Well, did you explain why those zeroed out?
Yeah.
Because the forces run through the center of rotation.
Oh yeah, I didn't explain that. The forces of the normal force and the gravity have no impact on any force which...
Yeah, they don't create any torque because they're running through the center of rotation.
And if there's no force, that means there's no torque, inevitably. Right? I think they kind of work together.
Right, you got to have a force to create torque.
Yeah, yeah.
Right. So then after we've canceled out the zeros, we're there.
Yeah, we've got the torque for F1 and the torque for F2, which are these 2. And so we find that torque equals R perpendicular F, and R
perpendicular is the radius of the pulley.
Yes.
So R perpendicular equals to R in this case.
Yes. And so then we factored out R, did a little algebra, and we found that all these R's cancel out. So then we're left with T1 plus T2 equals 1/2 ma. And we already know what T1 and T2 equals, so just plug those in. And
solve for A at that point.
yeah, we're not masters of all things algebra, so we have to figure this out. But up until this step, everything is good. We just have to figure out, we have to solve for A.
Yeah, and the only point I wanted to point out is that when you go from the torques to the forces, to the R perpendicular times force,
Yeah.
that's whenever, right here. And since R perpendicular is R, and our force is tension, we can just write it out like this.
Right, yeah, our force is our tension. That's a big one. Yeah, I didn't say anything about that.
Yeah, it's good. It's good to recognize.
The only force acting upon the masses or the blocks are the tension, so therefore the force equals the tension.
All right.
And so that's pretty much it for that one.
Good work.